Yes. Questions on the homework? Questions over the homework?
I actually thought it was going to be really hard, but I got it done.
Okay, I do have a point question real quick.
Yes.
Sorry about the homework. But my Math-O-Rama and a bonus thing were shown up as a 0 in the curriculum.
Mine are too.
Well, so bonus 0 out of a total of.
I have an F in your class.
Yeah, it should like grade out to 0.
Well, so simple points what I do in here. So it's the number of points you've earned over the total points given.
Oh, so
Those are the only two that have been put in. So you've earned
0 points.
and is out of.
Okay,
So
actually,
you can't divide by 0, but the grade book doesn't know what to do with that. Does that make sense?
Explain that to my mom. She was mad about that last night.
Yeah. And that's anytime any of the assignments come in and there's a 0 there, tell her or just check how much they're out of. Because if it's 0 out of 0, that's nothing. It's just bonus. Because if I put the bonus, you did the bonus, I'll put those in and they actually count as bonus points because they're out of 0, so it's going up. Because if I do bonus as a 1 out of 1, well, so your total points went up, that you earned it went up 1, but also the total amount. So it's not actually bonus, it's just another assignment. So bonus points, you're actually earning additional because it has to be out of 0.
I don't think my shoulder.
But I get that question every year.
Earlier, I was
Yeah.
like, how the heck do I have 100 that I have to miss your assignment? What is happening?
Well,
And then I figured out they were bonus, and I'm just thinking,
also for me, missing assignments is not zeros.
well, they show zeros on the.
Yeah, just to clarify, because I won't.
Yeah, I had 2 zeros and I saw it 100. And
Yeah.
I was like, what's happening? And then I realized that they're bonus.
Yep. All right. What we're looking at today is applying transformations to functions. So we'll be applying the transformations to the functions themselves. So 1-3 or 1-2, we were looking at what transformations were taking place. How far was moving up? How far was it moving down? Left, right, vertical shrink, or reflections. Now we're going to be taking a function and applying those transformations to it. Now for our horizontal translation, out of all this here, the key piece is this equation here, this f of x minus h. So I'd circle it, make some emphasis on it, because that is going to be key. It's going to be what we're going to use to apply a left or right movement, that horizontal translation to the function. Because that h value is going to tell us how far we're moving the function left or right. Our vertical translation, the key piece is this here. It's going to tell us how much it moves up and down. And we're going to be using f of x plus k, where k is that amount of movement. And again, I would be making sure to pay attention to these here because we're going to be using these two general forms of these equations to apply these transformations to the functions. Now, when we look at this first one here, so it says let f of x be 2x plus 1. And we want to write a function g whose graph is a translation 3 units down of the graph of f.
So g of x
Equals. So since we're going up and down, we're going to use the vertical translations general form.
it would be 3 units down. So it would be plus 4. Because that's the plus 1.
Not quite. But that's on the right path. So 3 units down. So our value of k is the movement up or down. So in our case, the value of k would be, the number would be 3. But it would be a positive 3 or negative 3.
It would be a positive. No, it's outside, so it's
So up is positive, down is negative. So our value of k, specifically the value of k, would be negative 3 because we're going down 3.
and since it's
Yes. For the most part, yes. Now, the next thing we're going to do is we're going to replace k with its value. Well, k's value is -3. So we replace k with -3. Okay. Now we need to replace f of x with its function, its equation.
2x.
And? Because f of x is what?
2x plus 1.
It's the whole equation. 2x plus 1 is our f of x. So when we plug x into f of x, or replace f of x with its function, we're replacing it with 2x plus 1 plus -3. Questions on this here so far? Our new equation. So, is there anything in front of the parentheses with 2x plus 1? So we can drop the parentheses. We don't need them. So it's just going to be 2x plus 1. Is there a number or negative sign in front of our -3 parentheses? No, so we can just drop the parentheses.
2x plus 1.
Because we could write it as plus -3, but that's the same as just -3. Combine like terms.
3x minus 3.
2x plus 2.
Oh, wait, yeah.
Because our only like terms are 1 and -3, and 1 minus 3 is -2. So our equation is 2x minus 2. So g of x is equal to 2x minus 2, which is our translation of 2 units down. 2x minus 2, if x is 1, the y value would be 0. Because 2 times 1 would be 2. 2 minus 2 is 0. But this is the equation if we move the function 3 units down. That's it. Questions on this here?
What's
We ready for the next one? Yes? Our next one is to write a function h whose graph is a translation 2 units to the left of the graph of f. Now our use of f of x, g of x, h of x, z of x, it's really just a way to name the function. That way we can distinguish between which one we're talking about without having to really specify the entire function itself. Now I'm going to rewrite f of x. You don't have to rewrite it. I'm rewriting it so that I'm not having to scroll up and down to reference back to it as we're working this problem. Now for this one here, we have a horizontal translation.
So we're using the same equation as the first one.
Yes, so both of these are applying back to that f of x. Now for horizontal translation, the general form is f of x minus h, because that's left and right, where h is our movement left or right. So how far are we moving to the left or to the right? 2. Now will the 2 be positive or negative?
So you're gonna go
Are we moving to the left or to the right?
to the right because it's in the parentheses.
That says to the left.
Wait, dang it, yeah, it's in the parentheses, so
Direction
it's
doesn't change.
that's opposite.
So it would be Negative 2. Since it's going to the left, it would be negative. And exactly as you said, because it's not in the parentheses yet, it's still left is negative, right is positive. But again, once we put it in the parentheses, the sign normally ends up flipping around, yes? So let's see if that still holds true. So our h of x, let's plug our value of h in for this here. So we'd have x minus.
It's a minus, so it's positive anyway.
So here, left, again, the value of h is negative. But at this point, when we're talking about it moving left, that value of h, we're not in the parentheses yet. But when we put it into the parentheses to apply this, we have x minus negative 2, which turns it to positive 2. Inside those parentheses, it's going to be the opposite of what we think. Does that make sense? And again, this, it takes us a little bit getting used to that flip that takes place there. Questions on this so far? So, what we have now, h of x is equal to our f of x plus 2, yes? All right.
Thanks for sharing.
Do we have f of x anymore? All right, guys. So we don't have f of x anymore. We have x plus 2. We replace the x in f of x with x plus 2. This means every x in f of x has to also be replaced with x plus 2. Now everything else is going to stay the same. Because this f of x plus 2, we will still have the 2. But we don't just have x anymore, we have x plus 2. Plus 1. Okay, so when we change, so now that we have f of x plus 2, every x in our f of x has to be changed to x plus 2. Because we've changed the x to x plus 2 inside our f of x. So does everything else. So it's this change from f of x to f of x plus 2. Every x on the other side has to change to x plus 2. Does that make sense? So the plus 1,
Remember we had to change that x.
so yep, it's just the x. Every other part of it stays the same.
Yeah, so it's literally just changing the x.
Yes. Now, I'm going to add this in. Because if we said it was 2x squared plus 1, and we applied this to it, we would have 2 times x plus 2 squared plus 1. So any powers that x had, if it was inside the absolute values, all of that stays. We're just taking x, pulling it out, and putting it the new one in. Does that make sense? And again, we haven't done it as too much in this context. You've done it with numbers, where you take f of 2, so replace every x with 2, and then evaluate it. Normally at that point you put it in the calculator. But we can do it with these here. We ready for the next step? Switch back to my colors. Distribute the 2. 2 times x is 2x. 2 times positive 2 is plus 4 plus 1. 4 plus 1 is? Now on the other side, we have this h of x equals f of x plus 2. Well, h of x is equal to f of x plus 2. So we don't have to keep writing f of x plus 2 because it is the same thing as h of x. So for us to move this function 2 units to the left, our new equation is 2x plus 5. Because moving it 2 to the left almost moved it 4 up, didn't it? Because we went from 1 to 5. So left and right does add some nuances to it.
So h of x equals f of x plus
2.
2 is just the same as saying h of x.
Yes, because they are equal to each other. So since there is equality there, we can replace them with each other. And it's a little bit easier to write h of x than it is to rewrite f of x plus 2 each time. Because that is what it is. The f of x minus h, which is our f of x plus 2, is that transformation of 2 units to the left of our original function, which we are now calling h of x.
Why do we do g of x for vertical? Why not just do v of x?
We could. They just decided to pick g.
Didn't you say it was because of velocity?
I think so, but some of the times we can pick what we want. Yeah, math is a little funny that way. We ready for the next one? Let f of x equal 4x minus 9. Write a function g whose graph is a translation 5 units up of the graph of f. So since we're talking about vertical, up, down, the general form for this is f of x plus k, where k is our movement up or down. Well, k's value for this here is positive 5.
Outside parentheses, so it stays positive.
And since it's moving up, it's positive. Have a good one. Now we could put parentheses around the 5, but we don't necessarily need them. We can put them and then drop them, but.
But that's a useless thing.
All right, questions on this so far? Now we need to replace, take care of our f of x.
So f of x equals a 4x minus 9.
So our f of x is 4x minus 9. That's what it's equal to. So we're replacing it with what it's equal to. Or if we talk about it in terms of how we did the last one with replacing the x with x plus 2, we could technically do that. But all I'm doing is replacing every x and f of x with x, which would change it from 4x minus 9 to 4x minus 9. Because that's all we're doing, we're putting x in place of x. But we don't normally say that because that's semi-confusing and it doesn't actually do anything. So we're really just replacing f of x with what it's equal to, which is 4x minus 9. Now, since there's nothing in front of its parentheses, there's no real just like the 5, we could have left them out. Which gives us 4x minus 9 plus 5, combined like terms, and we get
Negative
4x minus 4. Because our negative 9 plus 5 would be negative 4. And 4x minus 4. Questions on any of this so far?
Every problem thinks yeah, it's got heart attack.
Oh, yeah.
All right, guys. We want to write a function h whose graph is a translation 1 unit to the right of the graph of f.
H. But since it's in parentheses, technically it's negative, but it's going to be a positive. So
It's going to be a positive now, but when we put it in, it's going to be x minus 1. Because when we plug it in for its spot in the general form, we would get x minus 1. It is still 1 unit to the right, but once we put it inside the parentheses, it goes from looking like a positive 1 to a negative 1.
oh, seriously?
Are you serious?
We're sitting in here talking to us, and then he goes, "Oh crap!" Just runs out the door. I'm like, bye.
Yeah, I just did my.
Oh, seriously.
So I went to the office. He's like, oh, Sean.
Okay.
He was zooming down the road. He's going 80.
That's just
Somebody drives so bad. Like,
Well, it was funny because he told me that right. He was going 80 right after he told me he didn't enjoy the thrill of approaching. At its speed.
when was this last car chase?
All right, guys. So here we put in the value of h, giving us f of x minus 1. And since we replaced x and f of x with x minus 1, it means every x on the other side also has to be switched with
So we're using the same f of x as the top.
yes.
Do with the program.
Jonathan, shut up.
I don't know if I can switch over for it.
All right, guys, let's focus in here. We can talk about that more later. So here, we replace our x with x minus 1, giving us 4 times x minus 1, minus 9. So at this point, we can distribute the 4. 4 times x is?
4x.
4 times negative 1 is?
Positive. Or negative.
4 minus 9.
We must combine like terms.
Combine like terms.
Two negatives make a positive.
Multiplying 2 negatives would make a positive. A negative followed immediate, or a minus followed by a negative would make a positive. But subtracting,
And then it's h of x in front of the equal sign.
it would be h and x in front of the equal sign. But we have negative 4 minus 9. Because when we subtract a number from a negative, it just makes it a bigger negative.
Yeah, because if you
Making it, if you owe me $4, you can owe me 9 more.
Well, if you allow.
Yeah.
And math always math.
Math should,
Math should take a financial course.
yeah, math should tell me something else.
All right. Let's look at this next one here. F of x is equal to 3x. We want to translate this 5 units up. Well, they didn't tell us what to name the new function, so what do we want to name it?
No, wait, that word.
Oh,
No.
So our new function, what? B of x. We just need a letter.
Oh, he said, oh, okay. I thought he said anything else.
No.
so he said it just gave us the f of x so we get fixed.
Now the general form for vertical, going up or down, is f of x plus k. Now our k value in this case is 5. And since it's going up, it is positive.
It's outside parentheses.
Now, It was asked earlier if we have to do f of x and k at different times. We don't. Because if we want to, we can replace f of x at this point. F of x is
3x. 3x plus 5. That's right. It is.
because there are no like terms. So that's as far as it goes.
What did you say, Jonathan?
So because we can't chase the rabbit hole anymore.
What does that mean?
Well, because when in math you like follow the rabbit trail down and then until you come to rabbit trail. You already got it.
Oh, like you keep going down and down.
Yeah. Until you keep moving.
Yeah.
Can't believe I take something. I don't know. It was an analogy.
I've never heard of that before.
I haven't either, but
Did you ever watch, what's that movie called?
Lewis.
Alice in Wonderland.
Mm-hmm.
Well, yeah.
no, that
that's,
makes no
Rabbit
sense.
hole.
Yeah.
that's Alice in Wonderland.
That's where the expression.
Guys, that
I
movie's
heard down south and what's not the same.
All right, guys. We have one left, and then we are going to be done for today. F of x equals the absolute value of x minus 3 is translated 4 units to the right. So what's our letter that we're using for our new function?
Sorry.
Jonathan.
No.
What?
Jonathan, give me a letter.
Oh.
Oh.
Weirdo.
That's the second time O was picked today.
Oh, it's weird. It's random. That's right. And O's are all over this.
Now the general form is x minus h. Now our h in this case is
H equals
4. Now would it be positive or negative?
it's going right, so it would be positive.
Since it's going to the right, it would be positive.
Put it in the negative.
Fine.
Now when we replace h with its value in the general form, we get f of x minus 4.
There leaves us.
Now at this point here, we replaced our x with x minus 4, which means every x in the equation has to be replaced with x minus 4.
So,
Absolute value of minus 4 minus 3.
Are y'all still in math?
Well, I wasn't.
Now, since there's nothing in front of the parentheses inside the absolute values, we can drop those.
I'm not even kidding.
What's it from?
No. It was like a popcorn chicken bowl.
And that's it, because the negative 3 and the negative 4, they are like terms, but because of the absolute value bars, we cannot combine them.
Oh, because that's the absolute. Okay.
Negative 4 can't get any more times 7.
Well, we can't move anything inside or out, because we'd have to simplify whatever x minus 4 is, take the absolute value of it, and then subtract 3. We can't simplify it at this point.
Can't